In this video, we're going to talk about compression and clay. Unlike some of the other videos you'll be watching this semester, this video is not going to focus on a particular technique. Instead, we're going to focus on compression as a principle that you can apply across the board to any number of techniques. This is going to help you make what you want to make and, crucially, have your project survive the entire making process, especially firing. Compression is important when working with clay. When I say compression, I mean this quite literally. When we mold clay, when we pinch it, throw it, work with slabs, press it into molds, we are packing particles of clay together. It might help to look at some magnified images of clay. This is what kaolin looks like under a microscope. Notice how these particles are flat and wide. They're often compared to a deck of cards. Just think how much stronger a deck of cards is when it's packed together instead of spaced out and jumbled. Of course, the clay bodies we work with contain many ingredients. At a particulate level, they're not this homogeneous. Our clay contains plenty of grog, which is essentially fired clay that is ground up and adds strength to our work. But even with this grog, this is still a useful and easy principle to remember. By and large, packing particles so that they are densely bound is going to make our work stronger, and it's going to help that work survive the entire making process. Let's look at a few examples of making techniques and think about them from a compressive or particle packing perspective. First off, people who work with clay will often begin the making process with wedging. Wedging is a way of preparing clay for use. It's not always essential, but depending on what and how you're making, it can be. Wedging does a lot of things, two of which may seem almost contradictory. It both loosens your clay, making it easier to work with, and it begins packing and aligning clay particles. By now, you're also familiar with pinching as a technique. This is the artist Paul Briggs. Notice the way he touches and exerts force on his material, compressing clay between his fingers. He is not reworking the clay in different directions. He is applying force in a particular direction, compressing clay into precisely the shape he is looking for. This is also true when we look at Lee Kang-hyo, who uses a mix of coiling, pinching, and paddling. Think about how big these pieces are and the amount of force required to create the form and have that form make it through the firing process. Now, let's listen to the way Chris Gustin talks about the structural integrity of this platter and the need to create compressed, overlapping seams in the clay floor. It's clear that he is thinking about this work on a particulate level.
This crazy coloring moving action there. Wow. And he got it centered. Centered.
The way I'm going to do this is I don't want a seam that does this. Okay, so two pieces of clay coming together like that, because I'll never be able to get that tight enough, and when I fire it, it will crack. I want a seam that comes down like this, and comes down like that, comes down like that, and comes down like that. So I'm building layers of seams, not one seam. So what I do, first of all, I compress that.
Can you say why you cut the star across the middle? That surprised me.
Well, I cut this out.
Right.
Okay, do you see how that opened up?
Yeah.
If I didn't cut that, that would have been a big tear, big rip, because I got it squeezed together. So every action has a reaction. This action this way pulls everything apart that way. Action, reaction. So by slicing that, I just release it. Doesn't matter how thick it is, as long as it goes all the way across.
What if you just took one side across?
Yep. Just take it one side across first. And I'm compressing it, I'm pressing it down. Get that corner like that. This corner like that. Everything's coming together.
How did you figure this out? Did you, I mean, it probably cracked.
Bernard Leach,
Really?
Potter's book.
Oh, really?
That book is just gold mine of information. You just gotta read it.
When we fire our pieces in the kiln, it's important to remember that we are inducing a chemical and physical change in those pieces. Our work is transformed from raw clay into ceramic. This is, by nature, a stressful process. It's going to put the structural integrity of your work to the test. Don't worry, it's a test we all struggle with all the time. Just think, if we fire our work to what in the ceramics world is known as cone 6, that means we're submitting our work to roughly 2,230 degrees Fahrenheit, and that's only mid-range. High fire pieces are fired to what is known as cone 10, or approximately 2,345 degrees Fahrenheit. It's hot. Many metals melt at temperatures much lower than that. The more you delve into clay, the more you'll notice that certain types of clays are more susceptible or responsive to this stress, and that certain types of firings induce a greater amount of stress than others. In beginning ceramics classes, we often choose to work with a more robust clay body, one with plenty of grog. This adds strength to our work. And it means that even if clay particles aren't packed together as well as they could be, you still have a fairly good chance of your work surviving, or at least the majority of your work surviving. But if you continue your clay journey, as we very much hope you do, you're going to find that finer clays with smaller particle sizes that have a smoother, silky feel, are going to be even more responsive to this stress. They don't have those chunks of grogs to sustain them through the making process. So, compression is going to be important. This is especially true of porcelains and porcelaneous clay bodies. A good way to think of this is that some clay bodies have better memories than others. Say you're working with wet clay, you accidentally bump into it or drop it, then you fix it, or you think you do. But on a particulate level, instead of being packed together, the particles are jumbled. During the firing process, this is going to be a weak spot, and your piece may crack, warp, bend, or sink in this spot. This is not meant to intimidate you. Again, since we're working with a robust clay body, this is going to be much less of an issue. But it's a good thing to keep in mind right from the beginning. This is an incredibly tactile medium. Compress your clay well if you want to achieve a particular form. Think about the deliberateness with which you touch clay and begin to pay close attention to the way experienced clay artists work with their material. Of course, there are a lot of factors that influence the strength of your finished work. Compression or particle packing is just one of these, albeit a very important one. Of course, you may want the making process to be visible in your work. Maybe degradation, melting, collapse, cracking, warping are all physical and visual properties you're looking for. But if they're not, and actually, even if they are, thinking about compression or lack of compression will help you achieve the effects you want.